Step onto a bathroom scale in the morning and watch the number settle. You probably think that number is counting how much stuff you are made of, how much matter is packed into your body. It is not. It is weighing energy. Almost none of your weight, only about 1% of it, is the actual particles you are built from. The other 99% is pure energy, bound up and standing still inside you, pressing down on the scale and calling itself a body. And once you understand that mass is really just energy, a strange question sharpens into focus. Light is pure energy too. A beam of light warms your face, pushes on a solar sail, carries real energy across space. So why, if energy is mass, does light have no mass at all? And if a photon's energy does not come from mass, then where on earth does it come from? Get comfortable and settle in. Hit subscribe if you're new here, because by the end of this, the number on your scale and the warmth of light on your skin will both mean something they never meant before. Now, let's slowly ease into this. Part 1. The paradox you cannot unsee. There is a small contradiction that lives quietly in the mind of almost everyone who has ever learned a little physics, and once you notice it, it is very hard to stop noticing. It goes like this. Light carries energy. Nobody doubts that, because you can feel it. Sunlight warms your skin. It charges the panels on a rooftop. It can even push, ever so gently, on a thin metal sail floating in space, nudging a spacecraft forward, with nothing but the pressure of light. So a beam of light, a stream of the tiny particles we call photons, is unmistakably full of energy. And then there is the most famous equation ever written, the one that even people who never studied physics can recite. E equals mc squared. Energy equals mass times the speed of light squared. That equation says that energy and mass are bound together, two sides of the same coin. So here is the contradiction. If a photon has energy, and if energy and mass are the same currency, then surely the photon should have a mass equal to its energy divided by the speed of light squared. It seems to follow as simply as anything can. And yet every physicist, every textbook, every expert you could ask will tell you the same thing. Photons are massless. Light has no mass. Not a small mass, not a hidden mass, but exactly zero. And when you ask why, when you press for the reason behind this flat contradiction of the most famous equation in the world, the answers you get tend to feel strangely hollow. They will tell you that E equals mc squared does not apply to photons. And you will ask, why not? And they will say, because photons travel at the speed of light. And you will feel, if you are honest, that these are not really answers at all. They are a set of disconnected statements, a wall of assertions that never quite add up to understanding. You are told the equation does not apply, but not why. You are told it is because light is fast, but not how that follows. Each piece sounds authoritative, and together they leave you knowing less than you thought you did. I spent a long time stuck exactly there myself, collecting these fragments, and never being able to assemble them into a picture. And every attempt to look it up seemed to make it worse, because the explanations all assumed you already understood the thing they were supposedly explaining. They would wave at the equation, mutter something about rest frames, and move on, as though the answer were obvious. It is not obvious. It is genuinely subtle, and the reason it stays confusing is that everyone tries to answer it at the wrong level. They try to explain why the equation does not apply to photons, when the real problem is that almost nobody, including the people repeating the slogans, has ever properly understood what the equation says in the first place. The confusion about photons is really a confusion about mass itself, hiding in plain sight, and you cannot clear the one without first clearing the other. So we are going to be patient. We are not going to rush at the photon and try to force an answer out of it. We are going to circle back to the very beginning and rebuild the whole idea of mass from the foundation up, slowly and carefully, testing it against ordinary things you already have intuitions about, springs and coffee cups and thrown balls, until the meaning of that famous equation is solid under your feet. And only then, once the ground is firm, will we walk up to a beam of light and ask our question, and by that point, the answer will not feel like a trick or a technicality. It will feel inevitable, like the only thing that could possibly be true. That is the difference between being told an answer and understanding one, and understanding is what we are after tonight. I want to be honest with you about something, because it is the reason this video exists. That feeling, that sense of being handed slogans instead of understanding, is not a failure on your part. The contradiction is real, and the standard quick answers really are incomplete. But the confusion has a single source, one clean misunderstanding sitting underneath all of it, and once you fix that one thing, the whole knot comes apart in your hands. The paradox does not need to be argued away, it simply dissolves, and in its place, you get something much better than a resolution. You get an entirely new and more accurate picture of what mass actually is, what energy actually is, and why light, of all things, is the one thing in the universe with no weight at all. The misunderstanding is about the equation itself, about what E equals mc squared is really saying. Almost everyone reads it as a recipe for conversion, a rule for turning energy into mass and mass back into energy, as though they were two different substances with an exchange rate posted between them, like dollars and euros. That reading is wrong, and it is the source of nearly all the confusion. The equation is not about converting one thing into another. It is about revealing that they were never two things to begin with. But to see that clearly, and to feel why it means light must be weightless, we cannot start with light at all. We have to start somewhere much more ordinary, much closer to home. We have to start with a question so basic that it sounds almost too simple to bother asking, and yet almost nobody can answer it correctly. We have to start by asking what mass actually is. So that is the promise of this video, and I want to make it plainly so you can hold me to it. By the end, you will understand exactly why a photon can be bursting with energy and still have no mass whatsoever. You will understand where that energy comes from, if not from mass, which is the very question on the thumbnail. And you will get there, not by memorizing a rule, but by rebuilding your intuition from the ground up, one careful step at a time, until the answer feels not like a fact you were told, but like something you can see for yourself. There is a genuinely satisfying resolution waiting at the end of this. So let us begin where we have to begin, not with light, but with the most familiar thing there is, the solid weight of ordinary matter, and the strange truth of what that weight is really made of. Part 2. What is mass, really? Let us start with the question that sounds too easy to be worth asking. What is mass? If I put you on the spot, you would probably say something like this. Mass is the amount of stuff in an object. The more matter something contains, the more mass it has. A bowling ball has more mass than a tennis ball because there is more material packed into it. This is the intuition almost everyone carries, and it feels rock solid. Mass is a measure of how much stuff there is. It is the sheer quantity of substance. And for everyday purposes, this picture works well enough that you can go your whole life without it ever letting you down. But it is, at the most fundamental level, wrong. And the way it is wrong turns out to be the key to everything. To see the problem, let us follow the idea to its logical conclusion. If mass really is just the amount of stuff, then the mass of any object should simply be the sum of the masses of all the smaller things it is made of. Take yourself, for example. Your body has a certain mass, a number you can read off a scale, and your body is made of smaller pieces. So let us zoom in and take you apart, conceptually, to see where that mass comes from. What are you made of? At the first level, you are made of cells, and the cells are made of molecules, and the molecules are made of atoms. So far so good. Now go further. Each atom is made of a cloud of electrons surrounding a tiny, dense nucleus, and the nucleus is made of protons and neutrons. Go one level further still, because we can. Each proton and each neutron is itself made of even smaller particles called quarks, bound together in threes. And the electrons, as far as we know, are already fundamental, not made of anything smaller. So here we are at the bottom, at the most fundamental level physics has reached. Your entire body, all of it, is ultimately made of just two kinds of thing. It is made of quarks, bundled up into the protons and neutrons of every atomic nucleus in you, and it is made of electrons, swarming around those nuclei. That is it. Every atom of you, every cell, every bone and breath, reduces at the most fundamental level to quarks and electrons. So now, if mass is simply the amount of stuff, we have a clean and testable prediction. Your total mass should be exactly the sum of the masses of all the quarks and all the electrons in your body. Add up the mass of each tiny quark, add up the mass of each tiny electron, count every last one of them, total it all, and you should get your body weight. It has to work, if mass is really just how much stuff there is. The stuff is the quarks and electrons. Add up their masses, and you have added up all the stuff. And this really is what the everyday view of mass demands, if you take it seriously. When you say a bowling ball has more mass than a tennis ball because it has more stuff, you are making a claim about counting and adding. More stuff means more pieces, or heavier pieces, and the total is the sum. It is the same logic as saying a bag of coins weighs the sum of the coins inside it. Nobody would expect a bag of coins to weigh 100 times more than all its coins put together. That would be bizarre, a violation of the plainest arithmetic. So the everyday view of mass makes a firm, checkable promise. Weigh the whole, weigh the parts, and the two should match. This is not a straw man I am setting up to knock down. It is the honest, literal content of what almost everyone believes mass to be, and it deserves a fair test. So let us give it one, all the way down at the level of the fundamental pieces, and see whether the bag really does weigh what its coins weigh. Let me make this vivid, because the picture matters. Imagine you could shrink down, smaller and smaller, and travel into your own hand. You pass the surface of the skin, down among cells like great translucent balloons. You keep going, into a single cell, through its bustling machinery, until you reach a single atom, and it opens up into mostly empty space, a faint haze of electrons around a distant tiny core. You dive toward that core, and it resolves into a cluster of protons and neutrons packed tightly together. You pick one proton and go inside, and there, at last, you find them. 3 quarks, impossibly small, trembling and jittering in a storm of force that binds them together. This is the bottom. This is what you are made of, at the very end of the zooming in. 3 tiny quarks in every proton, 3 in every neutron, and the electrons far outside. These specks are your stuff, so they must, if the everyday picture is right, add up to you. And I want you to notice, on the way down, just how much emptiness you passed through. An atom is almost entirely empty space. If you scaled a single atom up until its nucleus were the size of a marble sitting in the middle of a stadium, the electrons would be tiny specks drifting somewhere up in the highest seats, with nothing at all in between. The solid, continuous surface of your hand, the thing that cannot pass through a tabletop, is mostly void, a scaffolding of forces holding a few flecks of matter apart, across relatively enormous distances. The solidity is an illusion woven by fields and forces, not a fullness of substance. This is worth holding on to, because it is the first crack in the idea that mass is a quantity of stuff. There is astonishingly little stuff down there. There is mostly empty space, held open and held together by energy. And already you might begin to suspect that whatever gives you your weight, it cannot simply be a tally of those few lonely specks scattered through all that emptiness. Keep that image in mind. the marble in the stadium, the near total emptiness of everything you think of as solid. Because in a moment we are going to add up those specks, all of them, every quark and every electron in your body, and the number we get is going to be so far from your actual weight that the everyday idea of mass will simply collapse. The emptiness you just fell through was the first hint. The sum we are about to do is the proof. Here is where the whole comfortable picture falls apart, and it falls apart completely. When you actually do the sum, when you add up the masses of all the quarks and all the electrons that make up your body, you do not get your body weight. You do not get anything close to it. You get about 1% of it, depending on exactly how you count, somewhere in the neighborhood of 1 to a few percent. That is all. The quarks and electrons, the actual fundamental stuff you are made of, account for only around 1/100th of your total mass. 99% of you, 99% of the number on the scale, is not the stuff at all. It is something else entirely, and this is not a rounding error or a measurement problem. It is a gigantic, gaping hole in the middle of the most basic idea we have about what mass is. If your stuff is only 1% of your weight, then where, in the name of everything sensible, does the other 99% come from? Part 3. The missing 99%. So we are left with a genuine puzzle, and it is worth sitting in it for a moment before we resolve it, because the resolution is one of the most beautiful ideas in all of physics. You step on a scale, and it reads some number. We have just discovered that only about 1% of that number is the actual matter you are built from, the quarks and the electrons. The remaining 99% has to come from somewhere. It is real. The scale is not lying. That weight is genuinely there, and gravity pulls on all of it, every last bit. So what is it? What is the 99% of you that is not made of stuff? To answer that, we have to go back inside the proton, back to those 3 trembling quarks, and look more carefully at what is happening down there. Because the answer is not another kind of particle. The answer is energy. Remember what we saw inside the proton, 3 quarks held tightly together. Now, what holds them together? They are bound by one of the fundamental forces of nature, the strong force, which acts like an incredibly powerful glue, tying the quarks to one another. And here is the thing about that binding. It takes a tremendous amount of energy to hold those quarks together in that tiny space, an amount of energy that is stored in the force field binding them, filling the interior of the proton. On top of that, the quarks themselves are not sitting still. They are whizzing around inside the proton at ferocious speeds, close to the speed of light, jittering and darting in that confined space. And all that motion is energy too, the energy of movement. So inside every proton and every neutron in your body, there is a roaring furnace of energy. There is the energy stored in the strong force binding the quarks, and there is the energy of the quark's own frantic motion. It is an enormous amount of energy, packed into an unimaginably small volume. Now here is the resolution, the thing that closes the gap. Take all of that internal energy, the binding energy of the strong force, plus the kinetic energy of the racing quarks, add it all up, and divide it by the speed of light squared. And what you get, precisely, is the missing mass, the 99%. That furnace of energy inside every proton and neutron, when you account for it through E equals mc squared, is where almost all of your weight comes from. Let me put some numbers on it, so you can feel the scale of the imbalance. A proton has a mass that physicists usually express in energy units, and it comes out to about 938 million electron volts. The 3 quarks inside it, their own intrinsic masses added together, come to only about 9 million electron volts. That is roughly 1%. The other 929 million, the overwhelming bulk of the proton's mass, is not the quarks. It is the energy of the strong force holding them and the energy of their motion. The proton is almost entirely a knot of energy, with a few tiny specks of matter caught inside it. It helps to picture the strong force honestly, because it is unlike anything in ordinary experience. The quarks inside a proton are bound by a force that behaves almost like an unbreakable elastic band. Try to pull two of them apart, and the force does not weaken with distance the way gravity or electricity does. It stays strong, or even grows, so that the quarks can never escape, forever snapping back toward one another. To hold three quarks in that permanent, straining embrace takes a colossal amount of energy, stored in the force field that fills the proton's interior like an invisible, humming tension. And the quarks, trapped in that tiny cage, are not resting. They are moving at speeds approaching the speed of light, careening around inside a space so small it defies picturing, and all that furious motion is more energy still. So the interior of a proton is not a calm little bag holding three marbles. It is a roaring, straining, high-speed storm of force and motion, and it is that storm, weighed through the equation, that becomes 99% of everything you are. Here is a way to feel the strangeness of it. If you could somehow reach into a proton and switch off the strong force, letting the quarks drift free and still, the mass would not stay behind in the quarks. It would mostly vanish, because it was never in the quarks, it was in the force and the motion. Your weight is not a pile of substance sitting quietly inside you. It is an ongoing event, a continuous storm of binding and motion that has to keep happening, moment to moment, to keep you as heavy as you are. You do not so much contain your mass as perform it, ceaselessly, in every proton and neutron, without ever pausing or noticing. The heft of your own hand is a process, not a possession. Take a moment to really feel what this means, because it is easy to say quickly and hard to absorb. The solidity of your own body, the heft of your arm when you lift it, the weight you feel pressing into a chair, is not, for the most part, made of matter at all. It is made of energy. It is the energy of forces and the energy of motion, locked inside the protons and neutrons that fill you, wearing the appearance of solid substance. If you could somehow strip away that internal energy and weigh only the bare particles, only the actual stuff, you would find that you had lost 99% of yourself. The person in the mirror is, overwhelmingly, not a collection of things. The person in the mirror is trapped energy, bound so tightly and moving so fast that it presses down on a scale and calls itself a body. There is far less stuff in you than there is caged energy pretending to be stuff. And this is not some fragile theoretical claim that hangs on a chain of assumptions. It is measured, directly, every day, in laboratories around the world. Physicists can weigh a proton with extraordinary precision, and they can add up the known masses of its quarks with equal precision, and the gap between the two is enormous and unmistakable, right where the internal energy says it should be. The same principle shows itself whenever a nucleus is built or broken apart. When light nuclei fuse together in the heart of a star, or heavy ones split apart in a reactor, the products weigh a little less than the ingredients, and that missing mass appears exactly as released energy, in the precise amount the equation predicts. This is the source of the sun's light and the power in a reactor alike, and it works, to the decimal place, because mass really is energy content. The fact that 99% of you is energy, rather than substance, is not a poetic flourish. It is arithmetic that engineers stake power plants on and that instruments confirm 1,000 times a day. It also quietly answers a question you might not have thought to ask, which is where all that energy inside you originally came from. The binding energy and the motion of the quarks in your protons were set long ago, in the first moments after those protons formed in the early universe, and they have been carried forward, locked in, ever since. Every proton in your body is an ancient, stable knot of energy, tied at the dawn of things, and never since undone. So when you feel the weight of your own hand, you are feeling energy that was bound up when the universe was young, held in the same tight configuration for billions of years, and still humming there now, in you, tonight. Your weight is, In a real sense, one of the oldest things about you. And this completely reframes the question we started with. We began by asking why a photon, which has energy, does not have a corresponding mass. But look at what we have just learned. You, who unmistakably have mass, are almost entirely energy yourself. Your mass and energy are not two separate things that happen to be related by an equation. Your mass, 99% of it, simply is energy, measured in different units. Which raises a much sharper version of the original question. If your mass is really energy, and a photon is pure energy, then why on earth does the photon not have mass too? Why does energy give you weight, but give light nothing? We are closing in on the heart of it now, but to get there, we have to take one more step, and it is the step that changes everything. We have to stop saying that energy is converted into mass, and start saying something far stranger and far truer. We have to consider the possibility that there is no such thing as mass at all. Part 4. There is no such thing as mass. When I told you that the energy inside a proton accounts for its mass, you probably heard it in a particular way. You probably heard it as a story about conversion. Energy gets converted into mass. The energy of the strong force somehow turns into the substance of the proton, transmuting from one thing into another, like water freezing into ice. That is how most people picture E equals mc squared. Two different things, energy and mass, with the equation acting as the exchange rate, telling you how much of one you get for a given amount of the other. And I understand why it is pictured that way. It is even how the equation is usually described. But it is not what is really going on, and the truth is stranger and, once you see it, much simpler. There is no conversion. Nothing is turning into anything. To see why, consider what the word conversion actually implies. It implies two distinct substances, and a process that changes one into the other, with a before and an after. But that is not what the proton is doing. The energy inside the proton is not becoming mass. It is not transforming. It just sits there, being energy, the whole time. So what is the mass then? Here is the reframing that unlocks everything, and I want you to hold on to it, because the rest of the video flows from it. The better way to understand E equals mc squared is this. There is no such thing as mass, not as a separate substance, not as a distinct kind of thing. What we have always called mass, every time we have ever weighed anything, is simply the energy content of that thing divided by the speed of light squared. We were never measuring two different quantities. We were always, only, measuring energy. Mass is just the name we gave to energy when we weighed it. Let that settle, because it is genuinely a different way of seeing the world. When you step on a scale in the morning, you probably think you are measuring how much matter is in your body. You are not. You are measuring how much energy is bound up inside you and dividing, in effect, by a very large number, the speed of light squared. The scale is an energy meter in disguise. The proton does not convert energy into mass, because there is no separate destination called mass for the energy to go to. The proton is a bundle of energy, and when you weigh it, you are weighing that energy. The mass and the energy were never two things. They are one thing, seen two ways, and the equation E equals mc squared is not a bridge between two lands. It is a statement that there was only ever one land all along, and that mass and energy are two words for the same territory. I know this is a strange thing to swallow, because the whole language we use fights against it. We speak of matter and energy as if they were opposites, as if matter were the solid, permanent stuff, and energy were the invisible, active spirit that flows between things. That picture is baked into ordinary speech, and it is exactly the picture that has to go. When a physicist looks at the equation, they do not see a rule for trading matter for energy at a fixed rate. They see a statement of identity, the way you might say that the morning star and the evening star are not two objects that transform into each other, but a single planet, seen at 2 times of day. Mass is not a thing that energy can become. Mass is what a certain amount of confined energy looks like when you put it on a scale. There is no exchange, because there is nothing to exchange it with. There is only energy, and weighing is one of the things you can do to it. Once you truly absorb this, a great many puzzles across physics quietly resolve themselves. And the photon is only the most famous of them. When a nuclear reaction releases energy, and the products weigh less than what you started with, nothing was converted. Some of the internal energy simply left, carried away, and so there was less energy left to weigh. When particles are created in a collider out of the energy of a crash, no substance was conjured from nothing. Energy that was there all along got bound up into new confined configurations that now register on a scale. Every one of these stories, told properly, is a story about energy moving from one form to another, with mass faithfully tracking however much of it stays confined and at rest. There is a single currency in the universe, and its name is energy. And mass is nothing more than the reading you get when you weigh the portion of it that is standing still. Now, you might be thinking, all right, but what about that stubborn 1%? The 99% I have explained. That is the internal energy of the proton, the binding and the motion, and I can accept that it is really energy being weighed. But the quarks and electrons themselves still have their own small intrinsic masses, the 1%. Surely that, at least, is real, honest, irreducible stuff. Surely the electron's mass is just what the electron is, a genuine little nugget of substance. But no. Even that dissolves into energy when you look closely. The intrinsic mass of a quark or an electron comes from its interaction with something called the Higgs field, a field that fills all of space. As these particles move through the Higgs field, they interact with it, and that interaction gives them an energy. And when you measure the mass of an electron, you are once again measuring an energy divided by the speed of light squared, the energy of its coupling to the Higgs field. Let me say a little more about that Higgs field, because it is where people often expect to finally find some solid, honest lump of substance, and they do not. The Higgs field is not a thing sitting inside particles. It is a field that fills all of space, everywhere, evenly, an invisible presence woven through the entire universe. Certain particles, as they move through it, interact with it, feel a kind of drag or resistance from it, and that ongoing interaction is what gives them their intrinsic mass. The more strongly a particle couples to the Higgs field, the more mass it has. But notice what this means. Even the so-called intrinsic mass of an electron is not a nugget of stuff the electron carries around. It is the energy of a relationship, the energy of the electron's constant interaction with a field that pervades space. Take away the field, and that mass would simply be gone, because there was never any substance there to begin with, only the energy of an interaction. So even at this last, most fundamental level, mass refuses to be a thing. It remains, stubbornly, energy, this time the energy of coupling to a field that fills the cosmos. So there is no flaw to this. There is no level at which you finally reach some pure, energy-free substance called mass. All the way down, from the 99% that is binding and motion, to the last 1% that comes from the Higgs field. It is energy, everywhere, always, divided by the speed of light squared. There is no such thing as mass. There is only energy, and mass is what we call energy when we put it on a scale. And now, at last, we have the tool we need to understand light. Because if mass is really just energy content, then the question of whether a photon has mass becomes a question about energy content, and that is a question we can actually answer. But there is a subtlety, one final crucial piece we have to understand first, and it is the piece that everyone who tries to reason about photons gets wrong. It has to do with a difference between two kinds of energy, and it is where we turn next. Part 5. the equation that means more than you think. Let us take the reframing we have just built and put it to work, because now that we understand mass as energy content, E equals mc squared becomes a far more powerful and intuitive tool than the mysterious slogan you learned in school. If mass is just the energy inside something, divided by the speed of light squared, then a wonderful prediction follows immediately. Anytime you add energy to the inside of an object, you should increase its mass. Any energy at all, stored in any way, should make the object weigh a little more, because you have increased its energy content, and mass is energy content. Let us test this idea against some ordinary examples, and watch how naturally it works. Take a simple metal spring sitting on a table. Now compress it, squeeze it down, and lock it in its compressed state. What have you done? You have stored energy in it. That is what a compressed spring is, a reservoir of elastic potential energy, ready to push back the moment you release it. You did work to compress it, and that work went into the spring as stored energy. So, according to our understanding, the compressed spring should now have a slightly greater mass than the relaxed spring, because it contains more energy. And that is exactly right. The compressed spring genuinely weighs more. The difference is fantastically tiny, far too small to ever detect on a kitchen scale, because you divide the stored energy by the speed of light squared, an enormous number, so the added mass is minuscule. But it is real. Compress a spring, and you make it heavier, because you have added energy to its insides. That is E equals mc squared, working in the most ordinary object imaginable. It is worth understanding why the effect is always so absurdly small in everyday life, because that smallness is the reason nobody ever notices it, and the reason the idea sounds unbelievable at first. The number you divide by is the speed of light squared, and the speed of light is about 300,000 kilometers every second. So the speed of light squared is a truly enormous number, a 9 followed by 16 zeros in the usual units. That means it takes an immense amount of energy to add even a whisper of mass. To add a single gram of mass to something, you would have to pour in roughly the energy of a large nuclear explosion. So when you compress a spring or heat a coffee, yes, the mass goes up, but by an amount so unimaginably tiny that no ordinary scale could ever register it. The mass and the energy are two readings of the same thing, but the exchange between the units is so lopsided that in daily life, the mass side barely flickers. This is exactly why the underlying unity of mass and energy stayed hidden from us for so long. It only becomes obvious when the energies get enormous, inside stars, inside nuclei, inside particle colliders, where the mass changes finally grow large enough to see plainly. Take another example, even more homely. You have a cup of cold coffee, and you heat it up. What is heat at the level of molecules? Heat is motion. When you warm the coffee, you are making its molecules jiggle and move faster, giving them more kinetic energy. The hot coffee has more internal energy than the cold coffee, stored in the faster motion of all those molecules. And so, once again, the hot coffee must have very slightly more mass than the cold coffee. By warming your drink, you have made it, imperceptibly, heavier. It sounds absurd the first time you hear it, but it is a direct and unavoidable consequence of what mass really is. Energy in, mass up. The hot coffee weighs more than the cold coffee by an amount equal to the added heat energy divided by the speed of light squared. Every time you heat anything, you increase its mass. Every time you compress or stretch or charge or excite anything, storing energy inside it, you increase its mass. This is a beautiful and consistent picture, and it is worth pausing to appreciate how much sense it makes. Mass is not some fixed, mysterious quantity of stuff that an object simply has. Mass is a running total of the energy locked inside a thing, and it goes up and down as you add or remove energy. It is dynamic. It responds. Add energy to the inside of an object, in any form whatsoever, and you add mass. The picture is unified and clean. There are no special cases, no exceptions, no mysterious rules. There is just energy content, and mass tracks it faithfully, always equal to the internal energy divided by the speed of light squared. If this were the whole story, the world would be simple, and you would already be well on your way to understanding photons. And the examples multiply the moment you start looking. Charge a battery, forcing energy into the chemical bonds inside it, and the charged battery weighs very slightly more than the empty one. Wind up an old clockwork spring, and the wound clock is imperceptibly heavier than the unwound one. Stretch a rubber band and hold it taut, and while it is stretched it carries a hair more mass than it did slack. Even a star, blazing away, is slowly losing mass, not because it is burning up substance in the ordinary sense, but because it is radiating energy away into space, and as that energy leaves, the star has less energy left inside it to weigh, and so it grows lighter. Our own sun sheds millions of tons of mass every second in exactly this way, simply by shining, converting a trickle of its internal energy into the sunlight that eventually warms your face. In every one of these cases, the same single principle is quietly at work. Put energy in, the mass rises. Let energy out, the mass falls. The object's weight is a running account of the energy locked within it, and that account is being updated constantly, in everything, everywhere, all the time, far below the threshold where you would ever notice. There is something quietly beautiful about living inside a universe like this, where the line between substance and energy that seems so obvious turns out to be no line at all. The warmth in a mug, the tension in a drawn bow, the charge in a cell, all of it has weight, because all of it is energy, and energy is what weight is made of. You have been surrounded your whole life by this seamless identity of mass and energy, without ever seeing it, because the speed of light is so large that it kept the connection whisper quiet. But it was always there, in every warm cup and every wound clock, waiting to be noticed. But there is a wrinkle, and it is the most important wrinkle in this entire video, because I have been careful, each time, to say energy added to the inside of an object. The energy in the compressed spring is inside it. The heat energy in the coffee is inside it. And it turns out that this word, inside, is doing an enormous amount of work I have been quietly leaning on this whole time. Because there is a kind of energy that does not count. There is a way of giving an object more energy that does not increase its mass at all, not even slightly. And figuring out exactly which energy counts and which does not is the final key that unlocks the mystery of the massless photon. So let us find the wrinkle. Let us find a case where you add energy to an object and its mass does not budge, and let us understand why. That case is about to overturn the simple picture we just built, and in overturning it, it will hand us the answer. Part 6. The ball that breaks the rule. We have built a clean and satisfying rule. Add energy to an object and its mass increases, because mass is just energy content divided by the speed of light squared. Compress a spring, heat a coffee, and you make them heavier. The rule feels airtight. So let us try one more example, one that seems just like the others, and watch what happens when the rule suddenly fails. Take a tennis ball, resting on a table. It has a certain mass, a certain weight. Now pick it up and throw it. The moving tennis ball, flying through the air, has kinetic energy, the energy of its motion, which the resting ball did not have. You have given it energy. According to the rule we just built, more energy should mean more mass. So the moving tennis ball should weigh more than the stationary one. It has more energy, therefore it should have more mass. That is what our rule says. And it is wrong. The moving tennis ball has exactly the same mass as the stationary one. Not a tiny bit more. Exactly the same. This should stop you in your tracks, because it seems to directly contradict everything we just established. We heated the coffee, and it gained mass. We compressed the spring, and it gained mass. Both times, we added energy and the mass went up, just as the rule promised. Now we throw the ball, giving it kinetic energy, adding energy in a perfectly real sense, and the mass does not move at all. What is going on? Why does the energy of heat count, and the energy of a compressed spring count, but the energy of a thrown ball does not count? They are all energy. If mass is energy content, and the moving ball has more energy, why doesn't it have more mass? This is the exact question that, once answered, dissolves the entire mystery of the photon. So let us not rush past it. Let us feel the full force of the contradiction first. Because at first glance, the moving ball really does seem to sit in exactly the same category as the heated coffee. In both cases, you did work. You spent energy from your own body to throw the ball, just as you spent energy from a stove to heat the coffee. In both cases, that energy went somewhere. It did not vanish. The coffee got hotter, the ball got faster. Energy in, effect out, both times. So if the heated coffee weighs more, because you put energy into it, then by every ounce of consistency, the thrown ball should weigh more too, because you put energy into it as well. There is no obvious difference in the act. You did work, energy flowed, the object changed. And yet the scale disagrees, insisting the coffee is heavier and the ball is not. Something about these two apparently identical situations is secretly, importantly different, and the ordinary way of thinking about energy gives you no clue what it is. That hidden difference is the whole prize, and it is why we cannot simply wave the puzzle away by saying kinetic energy is special. We have to find out precisely what makes it special. You might think, at first, that maybe kinetic energy is somehow not real energy, that motion energy does not count the way heat energy does. But that cannot be right, because kinetic energy is as real as any energy there is. A moving ball can break a window, do work, transfer its energy to other things. When a comet slams into a planet, it is the kinetic energy of its motion that carves out a crater the size of a country. Motion energy is thoroughly, undeniably real. So it is not that the thrown ball's energy is fake. The energy is real, and yet it adds no mass. The rule, as we stated it, is broken, and we need to understand why. Because the repair we make to the rule is the answer we have been chasing all along. Let me sharpen the puzzle even further, because there is a detail here that makes it stranger still. How fast the tennis ball is moving, and therefore how much kinetic energy it has, depends entirely on who is watching. To you, standing still, the thrown ball moves quickly and has a lot of kinetic energy. But imagine someone running alongside the ball at the same speed. To them, the ball is barely moving at all, and has almost no kinetic energy. And to someone on a train speeding the other way, the ball has an enormous amount of kinetic energy. So the ball's kinetic energy is not one fixed number. It is different for every observer, depending on their own motion. Now, if that kinetic energy contributed to the ball's mass, then the ball's mass would also be different for every observer. You would say the ball has one mass, the runner alongside it would say it has a smaller mass, the person on the train would say it has a larger mass. The mass of a single tennis ball would depend on who was looking at it. And that is clearly absurd. The ball is just a ball. It cannot have a different amount of mass for every person in the room. Let me press on this a little, because the observer dependence is the sharp edge that cuts the puzzle open. Think of any real, physical property of the ball, something intrinsic to it. The number of atoms in it does not change depending on who is looking. Its color does not change. Its temperature does not change. These are facts about the ball itself, and everyone, no matter how they are moving, agrees on them. But the ball's kinetic energy is not like that at all. It is entirely a statement about the ball's motion relative to some particular observer, and there is no single true value of it. To you it is large, to the runner beside it nearly zero, to the oncoming train enormous. Kinetic energy is not something the ball has in itself. It is something the ball has with respect to you. And mass, whatever else it is, has to be something the ball has in itself. A fact everyone can agree on, or the whole concept falls apart. So a quantity that changes depending on who is watching cannot simply be poured into a quantity that must stay the same for everyone. The two are different kinds of thing. You can sharpen it with an even starker example. Picture a bullet fired from a gun. To someone standing on the ground, that bullet has a great deal of kinetic energy, enough to do terrible damage. But now imagine a second bullet, fired from a second gun, flying alongside the first at exactly the same speed and direction, side by side. From the point of view of the first bullet, the second bullet is not moving at all. It just floats there, motionless, a harmless piece of metal hanging in the air beside it. Same bullet, same speed through the ground. And yet its kinetic energy is either lethal or zero, depending entirely on who is asked. If that observer-dependent energy contributed to the bullet's mass, the bullet would have two different masses at once, which is nonsense. So the resolution cannot be that kinetic energy is fake. It is that kinetic energy, real as it is simply not the kind of energy that mass is made of. And naming exactly what kind of energy mass is made of is the task of the next part. So something has to give. The kinetic energy of the ball is real, but it depends on the observer, and mass cannot depend on the observer. So kinetic energy cannot simply add to mass the way heat does. There must be a difference, a fundamental difference, between the kind of energy that heat and compression add and the kind of energy that motion adds. One kind changes the mass, the other does not. And the distinction between them is the whole secret. Once we name it precisely, once we can say exactly what separates the energy that counts from the energy that does not, we will be able to walk straight up to a photon and settle the question of its mass once and for all. So let us name the distinction. Let us figure out what the heated coffee has that the thrown ball does not, and why only one of them gains weight. Part 7. Inside versus outside. Here is the resolution, and it is so simple that once you see it, you will wonder how it could ever have been confusing. Think again about the two cases side by side. When we heated the coffee, we made its molecules move faster, jiggling in place, bouncing off one another more violently. That added energy went into the internal state of the coffee. The coffee, considered as a whole object sitting on the table, was not going anywhere. It was still, but inside it, the molecules were more agitated than before. We changed what was happening within the object. We added energy to its insides. The same is true of the compressed spring. The spring as a whole sits still on the table, but inside it, its coils are strained, storing energy in the tension of its own structure. In both cases, the energy went inside. The internal condition of the object changed. Now think about the thrown tennis ball. When you throw it, what happens inside it? Nothing. Its molecules are not jiggling any faster than before. Its temperature is exactly the same as when it sat on the table. There is no new energy stored in its structure, no internal strain, no extra vibration among its parts. Inside the ball, everything is precisely as it was. The only thing that changed is that the whole ball, as a single unit, is now moving through the room. The energy you added is not inside the ball. It belongs to the ball's motion as a whole, its motion relative to you, the observer. And that is the entire difference. Heat and compression add energy inside the object, changing its internal state. Motion adds energy to the object as a whole, without touching anything inside it, and only the energy inside counts as mass. Let me give you a way to feel this in your bones, a simple test that makes the distinction physical. Suppose you wanted to weigh that moving tennis ball, to find its true mass. How would you do it honestly? The cleanest way is this: run alongside the ball at exactly its speed, so that, from your point of view, the ball is no longer moving. It hangs there, in the air beside you, motionless, as still as if it were resting on a table. Now look at it. It is identical to a stationary ball. All that kinetic energy you thought it had is simply gone from your point of view, because you are moving with it. And this is the giveaway. If the kinetic energy were really inside the ball, part of its substance, you could not make it vanish just by running alongside. When you heat the coffee, you cannot cool it down by running past it. The internal energy stays, no matter how you move. But the kinetic energy of the ball disappears the instant you match its motion, which proves it was never inside the ball at all. It was a feature of the relationship between the ball and you, not a property the ball carried within itself. Notice how neatly this test sorts every case we have met. Run alongside the heated coffee, matching whatever motion it has. And does the heat go away? No. The molecules are still jiggling, the coffee is still warm, the internal energy is still there, because that energy was never about the coffee's motion relative to you. It was locked inside. Run alongside the compressed spring, and does the tension release? No. The coils are still strained, the stored energy still present, because it too lives inside the object, indifferent to how you move. But run alongside the thrown ball, and its kinetic energy vanishes completely, because that energy was only ever the ball's motion, as seen by you, and once you share that motion, there is nothing left. The test is a perfect sieve. Whatever energy survives when you move into step with an object, whatever stays no matter how you chase it, that is the internal energy, the real rest energy, and that is what has weight. Whatever disappears the moment you match the object's motion was never inside it and never had any weight to give. This is why physicists trust rest energy as the true measure of mass, and it comes down to agreement. The rest energy is the one energy that every observer in the universe can agree on, because it is defined by going into the object's own rest frame, the one frame the object itself picks out. No matter who you are or how you are moving, if you want the object's rest energy, you do the same thing. You match its motion and measure what is inside, and you all get the same number. Mass, then, is the part of the energy that belongs to the object alone, stripped of the accident of who happens to be watching it move. It is the energy an object would have if the whole rest of the universe stood still around it. That is a solid, objective, observer-independent thing, exactly the kind of thing mass ought to be, and it is why, of all the energy an object might carry, only this restful, interior, agreed-upon portion earns the name of mass. So now we can state the rule correctly, repaired and precise. Mass is not the total energy of an object divided by the speed of light squared. Mass is the internal energy, the energy an object has when it is sitting still, the energy that is genuinely inside it, divided by the speed of light squared. Physicists have a name for this internal, sitting still energy. They call it the rest energy. It is the energy the object has in its own rest frame, the energy you measure when you are moving right along with it so that it appears at rest. That rest energy is what mass really is. The energy of motion, the kinetic energy, which depends on who is watching and vanishes when you move alongside, does not count. It is not part of the mass. Only the rest energy, the energy confined inside, the energy everyone can agree on because it does not depend on anyone's motion, that is the mass. This is why the heated coffee gains mass and the thrown ball does not. The heat is rest energy, inside the coffee, there for every observer, regardless of their motion. The kinetic energy of the ball is not rest energy. It is out there, in the relationship of motion, different for every observer, vanishing when you keep pace. And now you can perhaps feel where this is going, because we set out to understand a particle of light, and we have just learned that to find something's mass, you have to find its rest energy, the energy it has when it is standing still. So a natural and dangerous question rises up. What is the rest energy of a photon? What energy does a beam of light have when it is standing still? To answer that, we would have to bring a photon to rest, run alongside it, and look at it sitting motionless, the way we did with the tennis ball. And that, as we are about to discover, is where the whole universe puts its foot down and says no. Part 8. The energy that is standing still. Let us pause here and gather everything we have learned into one clear picture, because we have covered a great deal of ground, and the pieces are about to lock together into the answer. We started by asking what mass is, and we found that the everyday answer, mass as the amount of stuff, is almost entirely wrong. We discovered that 99% of your own mass is not stuff at all, but energy, the binding energy and the motion energy trapped inside the protons and neutrons of your body. Then we took the crucial step and reframed the famous equation. There is no such thing as mass as a separate substance. Mass is simply energy content divided by the speed of light squared. When you weigh something, you are weighing its energy. That is what E equals mc squared really means. Not a recipe for conversion, but a statement that mass and energy were always one thing. Then we hit the wrinkle, and the wrinkle turned out to be everything. Not all energy counts toward mass. We compared the heated coffee, which gains mass, with the thrown ball, which does not, and we found the dividing line. The energy that counts is the energy inside an object, its internal energy, the energy it has when it is sitting still. The energy that does not count is the energy of motion, the kinetic energy that depends on who is watching and disappears the moment you move alongside the object. And we gave the energy that counts its proper name. It is the rest energy, the energy an object has in its own rest frame, when it is standing still relative to you. Mass, properly understood, is the rest energy divided by the speed of light squared. That is the corrected, precise rule. Not total energy, rest energy. So let us hold that thought clearly, because it is the whole game now. Any object's total energy can be split into two parts. There is its rest energy, the energy it has just sitting there, confined inside it, the energy that is the same for every observer. And there is its energy of motion, its kinetic energy, which is added on top when the object moves, and which is different for every observer depending on their own motion. The total energy is the sum of the two, and when you want the mass, you throw away the motion part and keep only the rest part. Mass is the rest energy alone, divided by the speed of light squared. The motion energy is real. It can break windows and carve craters, but it is not mass, because it is not inside the object. It is a feature of the object's motion relative to you. This gives us a completely general method for finding the mass of anything, a recipe we can apply to any object in the universe. First, get into the object's rest frame. That is, move alongside it at exactly its speed, so that it appears, to you, to be standing perfectly still. Second, now that it is at rest before you, measure all the energy it contains, all the energy that is genuinely inside it, the binding energy, the internal motion of its parts, everything confined within. That is its rest energy. Third, divide that rest energy by the speed of light squared, and you have its mass. This works for a tennis ball, for a proton, for a star, for anything. Match its speed, bring it to rest before your eyes, weigh the energy inside, and there is the mass. It is a clean, universal procedure, and it never fails. Let me slow down here and let the whole structure of the argument settle, because everything now hangs on it, and it is the kind of thing that rewards a second, calmer pass. We began with the belief that mass is a quantity of substance, and we watched that belief fail, because the substance in you accounts for only 1/100th of your weight. We replaced it with a truer idea, that mass is energy content, that weighing is weighing energy. Then we refined even that, because not all energy counts. We separated the energy that lives inside an object, its rest energy, from the energy of its motion through the world, and we found that only the interior, restful energy has weight. Mass is the energy of standing still, divided by the speed of light squared. Each step made the previous picture feel a little too simple, and each correction brought us closer to something that actually holds together. This is how understanding is built, not in a single leap, but by refining a rough idea again and again until it stops breaking. Notice, too, that every refinement we made was forced on us by an ordinary object refusing to behave. The everyday idea of mass broke on the humble fact that your own body weighs 100 times more than the particles inside it. The idea of mass as total energy broke on a thrown tennis ball, which gains energy but not weight. At no point did we reach for anything exotic to overturn the picture. It was always a spring, a coffee, a ball, a scale, the most common things in the world, quietly insisting that our understanding was not yet good enough. That is worth remembering, because it means everything we have concluded, however strange it sounds, is anchored in things you could test on a kitchen table if your instruments were sensitive enough. The masslessness of light, when we reach it, will not be a leap into fantasy. It will be the same careful reasoning, carried one step further, to an object that happens to be made of pure motion. And there is a certain peace in where we have landed, a simplicity worth resting in for a moment before the final turn. Mass is not a mysterious substance. It is not a fixed and separate thing. It is simply the energy an object holds when it is left alone and at rest, the quiet, interior energy that stays with it no matter who watches or how they move. Your own weight is the rest energy of all the storms of force and motion inside your protons and neutrons, held still as a whole, even as they rage within. A coffee's warmth, a spring's tension, a star's fading glow, all of it is rest energy. All of it has weight. All of it is the same single currency, counted the same single way. There is a real elegance in it, a sense that the universe is not cluttered with different kinds of stuff, but woven from one thing, energy, appearing now as heat, now as motion, now as the heft of a body on a scale. Hold that calm, unified picture steady in your mind, because we are about to carry it toward the one object that will test it to its limit, and either break it or crown it. We are about to carry it toward light. Except, perhaps, in one case, because notice that the very first step of the procedure requires you to bring the object to rest, to move alongside it until it stands still before you. For a tennis ball, easy. For a planet, harder, in practice, but perfectly possible in principle. For anything made of matter, you can always, at least in your imagination, run fast enough to catch up and bring it to rest. But we have been building toward a particular object, an object that is not made of matter, an object that is pure energy racing through space. We have been building toward the photon, the particle of light. And when we try to apply our beautiful universal procedure to a photon, when we try to take that very first step and run alongside it until it stands still, we are going to run headlong into the strangest and most important fact in all of relativity. We are going to try to catch the light, and we are going to fail, in a way that turns out to be the entire answer. Part 9. Chasing a beam of light. So let us do it. Let us take our universal procedure for finding mass and apply it, carefully, to a single photon, a single particle of light, and see exactly where it leads. First, though, let me point out the mistake that started this whole confusion, because now we can finally see clearly what was wrong with it. When people first try to give a photon a mass, they take the photon's energy and divide it by the speed of light squared, and they call that the mass. But look at what they are doing. They are taking the photon's total energy and dividing by the speed of light squared. And we have just learned, at some cost, that mass is not total energy divided by the speed of light squared. Mass is rest energy divided by the speed of light squared. So the very first move, dividing the photon's total energy, was already the error. To find the photon's mass, honestly, we must not use its total energy. We must find its rest energy, the energy it has when it is standing still, and divide that by the speed of light squared. Everything now depends on finding the rest energy of a photon. So let us follow the procedure, step by step, exactly as we would for a tennis ball. Here is our photon, streaking across space. Step 1. Get into its rest frame. Run alongside it, matching its speed, until it appears to be standing still in front of us. And then we can measure the energy inside it. Simple enough. We did it with the ball. We just need to move at the photon's speed, so that relative to us, it is at rest. So how fast is the photon moving? It is moving at the speed of light, because that is what light does. The photon travels at roughly 300,000 kilometers every second, the fastest anything can go. So to bring it to rest, to pull up alongside it and watch it hang motionless before us, we would need to travel at the speed of light ourselves. We would need to move at 300,000 kilometers a second, right next to the photon, keeping pace so that it appears to stop. And here, the moment we try, the universe stops us cold, because it turns out you cannot travel at the speed of light. Not you, not a spaceship, not anything made of matter. It is forbidden, and forbidden in a very specific and unbreakable way. According to relativity, the faster you go, the more energy it takes to go faster still, and not in a gentle way. As your speed climbs closer and closer to the speed of light, the energy required to keep accelerating climbs faster and faster, ballooning without limit. To actually reach the speed of light, you would need to put an infinite amount of energy into the acceleration. Infinite. Not a very large amount, but a literally unlimited, impossible amount. There is not that much energy in the universe, and there never could be. So you can get closer and closer to the speed of light, but you can never arrive. The speed of light is a wall that nothing with mass can ever reach, no matter how much energy you pour into the effort. Let me make this vivid, because it is worth feeling the impossibility directly. Imagine you are in the fastest spaceship ever conceived, and you decide to chase a beam of light. You fire your engines and accelerate. You reach half the speed of light. The beam is still pulling away from you. You push harder, burning unimaginable amounts of fuel, and you reach 90% of the speed of light. The beam still races ahead. You pour everything you have into it, reaching 99%, then 99.9%. Your engines straining against a cost that grows more brutal with every fraction of a percent. And no matter how close to the speed of light you get, the beam of light ahead of you keeps its distance, never slowing, never letting you gain. You are pouring in more and more energy for less and less gain. And the wall of the speed of light stands there, absolute, unreachable. You will never pull alongside that photon. You will never bring it to rest. The very first step of our procedure, the step that worked for every object made of matter, is impossible for light. It is worth understanding why the cost of acceleration climbs the way it does, because it is not arbitrary. It is woven into the structure of space and time itself. In ordinary life, if you push something steadily, it speeds up steadily, and a fixed push always seems to buy the same gain in speed. But that is only true at the low speeds we are used to. As you approach the speed of light, the same push buys less and less speed, and it takes ever more energy to squeeze out each additional fraction. It is as though the speed of light were a wall you are pushing a cart toward, and the closer you get, the steeper and stickier the ground becomes, so that the last stretch to the wall would take an eternity of effort you can never finish. The energy you must supply does not just grow, it grows without any ceiling, heading toward infinity as your speed heads toward that of light. And since there is no infinite supply of energy anywhere, the wall stays forever, just out of reach. This is not a limitation of our engines or our technology. It is a feature of the universe. Nothing with mass can ever be brought all the way up to the speed of light, because the universe charges an unpayable price for the final step. So already, before we even get to the strangest part, something is off about our plan to weigh the photon. Our whole procedure for finding mass began by bringing the object to rest, and to bring a photon to rest, we would have to travel at light speed, which the universe forbids to anything with mass. We cannot take even the first step. And here you might feel the first cold hint of the answer beginning to form, though it is not yet complete. There is something about a photon that resists the very operation by which we define and measure mass. It will not let us into its rest frame. It will not hold still for us. And a thing that can never be brought to rest is a thing whose rest energy we can never find, which is already a strange and suggestive place to be. But the full force of it only lands when we stop trying to reach light speed exactly and settle for merely getting close. Because what happens then is stranger than a simple impossibility. What happens then breaks our intuition about motion entirely. Now, you might think there is a clever way around this. All right, you say, I admit I cannot reach the speed of light exactly, but I do not need to. Let me just get very, very close. Let me travel at 99.999% of the speed of light. That only takes a finite amount of energy, a lot, but finite. And surely, moving that fast, I would see the photon almost at rest, barely creeping ahead of me, nearly frozen. And from that, I could figure out its rest energy. It is a reasonable thought. It is exactly the kind of clever workaround that ought to save us. But it does not work. And the reason it does not work is the strangest and most beautiful fact in all of relativity, and it is where we turn next. Because when you chase that photon at 99.999% of the speed of light and look ahead, you do not see it creeping slowly in front of you. You see something that should be impossible. Part 10. The thing that is never at rest. Here is what happens when you chase the photon at 99.999% of the speed of light, and look ahead to see it nearly frozen. It is not frozen. It is not creeping. It is racing ahead of you at the full speed of light, exactly as fast as if you were standing completely still. Read that again, because it is one of the strangest truths in physics. No matter how fast you move toward a beam of light, no matter how much you accelerate, the light always moves away from you at the same speed, the full speed of light, 300,000 kilometers a second, relative to you. You can be sitting in a chair or flying at 99.999% of light speed. And in both cases, when you measure the speed of that photon, you get the exact same number. The light does not slow down for you. It cannot be gained on. It flees from everyone at the same unchangeable speed. This is the principle at the very foundation of Einstein's relativity, the fact from which everything else in the theory flows. And it is worth pausing to feel just how much it violates common sense, because relativity earned its strangeness honestly. In ordinary life, speeds add up. If you are on a train moving at 100 kilometers an hour, and you walk forward down the aisle at 5, then to someone on the ground you are moving at 105. Throw a ball forward from a moving car, and its speed relative to the road is the car's speed plus the throw. This is so obviously true that it feels like a law of logic rather than physics, and yet light refuses to obey it. Shine a flashlight forward from a speeding train, and the light does not travel at the speed of light plus the speed of the train. It travels at exactly the speed of light, the same as if the train were parked. The speeds do not add. Nature simply will not let anything, by any trick of motion, measure light going at anything other than its one fixed speed. This was so contrary to expectation that accepting it required physicists to rebuild their understanding of space and time themselves, allowing clocks to run slow and lengths to contract, all so that the speed of light could come out the same for everyone. The speed of light is the same for every observer, regardless of how that observer is moving. A person standing still measures light going at the speed of light. A person chasing it at nearly light speed also measures it going at the speed of light. There is no reference frame, no matter how fast, in which light is slowed down, and certainly none in which it is brought to rest. And now you can see the trap close, the trap we have been walking into since we tried to weigh the photon. To find the photon's rest energy, we needed to bring it to rest, to find a frame in which it stands still. But there is no such frame. There cannot be. Light moves at the same speed for everyone, which means there is no observer anywhere in the universe, moving at any speed, who ever sees a photon at rest. The photon is never, to anyone, standing still. And this, at last, is the answer. This is why photons are massless. Follow the logic, because every piece is now in place. Mass is rest energy divided by the speed of light squared. Rest energy is the energy an object has when it is standing still. But a photon is never standing still, in any reference frame, for any observer, ever. There is no frame in which the photon is at rest, so there is no such thing as the photon's rest energy. It simply does not have one. And if it has no rest energy, then it has no mass, because mass is just rest energy divided by the speed of light squared, and the photon's rest energy is not small, not hidden, but non-existent. The photon has no mass because it has no rest. It is not that we have failed to find the photon's mass, it is that the very thing mass is made of, the energy of standing still, does not exist for light, because light never stands still. Take a moment to feel how genuinely alien this is, because our whole intuition about motion is built on the idea that speed is relative, that whether something is moving depends on your point of view. A car on the highway is racing past a tree but sitting still relative to the car beside it. A passenger walking down the aisle of a plane is strolling slowly to the other passengers and hurtling at hundreds of kilometers an hour relative to the ground. For everything made of matter, motion is a matter of perspective, and by choosing your perspective, you can always find a frame in which the thing is at rest. Light shatters this completely. There is no perspective, none, in the entire universe, from which light is at rest or even slowed. Chase it as hard as you like, and it retreats at full speed. Point yourself the other way, and it approaches at full speed. Every possible observer, moving in every possible way, agrees that light moves at exactly the same speed. Light does not participate in the relativity of motion the way everything else does. It is absolute in its fleeing, the one thing whose motion no one can ever escape or match. And so we arrive at the answer to the question we opened with, though not yet the whole of it. Why is a photon massless? Because mass is rest energy, and a photon has no rest, in the most complete sense imaginable. No rest for anyone, ever. But you will have noticed that a piece is still missing. A photon plainly has energy. We can feel its warmth, harness it, be pushed by it. If none of that energy is rest energy, if there is no interior, standing still energy at all, then what is the energy of a photon? Where does it live, and where does it come from? The answer is that it lives entirely in the photon's motion, in a quantity called momentum, and there is a fuller form of Einstein's equation that shows exactly how. But before we can reach it cleanly, we have to face a clever objection, one that threatens to undo everything we have concluded by simply changing the definition of mass. Because a determined skeptic could say, fine, the photon has no rest energy, but who said mass has to be rest energy? Let me define mass differently, and give the photon a mass after all. And to honor our promise of looking at this from every angle, we have to take that objection seriously. Sit with the strangeness and the beauty of that for a moment, because it is one of the most remarkable facts about our universe. A photon is a thing that is never at rest. Not to you, not to me, not to a rocket chasing it at almost its own speed. It flees from all of us identically, always in motion, never pausing, with no still center anywhere inside it. Everything else in the universe, every particle of matter, every planet and person, can in principle be brought to rest, can be caught up with and made to stand still, and whatever energy remains when it is still is its mass. Light alone can never be stilled. It is pure motion, energy with no resting place, forever racing. And because it has no rest, it has no rest energy. And because it has no rest energy, it has no mass. The masslessness of light is not a strange exception to the rules. It is the direct and necessary consequence of light being the one thing that never, ever stops. But now we come back to the question on the thumbnail, the question we have not yet fully answered. If the photon has no mass, where does its energy come from? Because it certainly has energy. Sunlight warms your face. It is bursting with energy. If that energy does not come from mass, if there is no rest energy at all, then what is the source? And the answer is now within reach, and it is elegant. The photon's energy comes from its motion, from its momentum. We are used to thinking that only massive things moving fast carry a punch. But light, it turns out, carries momentum without any mass at all, and its energy is the energy of that pure motion. There is a fuller version of Einstein's equation, one that includes both the energy of rest and the energy of motion. And when you apply it to light, it tells you exactly where the energy lives. That fuller equation, and one final twist about the true speed limit of the universe, is where we are heading now. But first, we have to deal with an objection, a clever objection, one that threatens to unravel everything we have just concluded. Part 11. The other way to weigh a photon. I promised you at the start that we would look at this from every angle, and there is an angle we have not yet faced, an objection that is genuinely clever and deserves a real answer. Here it is. We concluded that a photon is massless because it has no rest energy, but that whole argument depended on defining mass as rest energy divided by the speed of light squared. And someone could reasonably object, why should we define mass that way? Why not define mass differently? After all, if mass is just a word we use for energy content, then maybe I am allowed to choose which energy I mean. So let me propose an alternative definition. Let me define the mass of an object as its total energy, all of it, the rest energy plus the motion energy, divided by the speed of light squared. I will not throw away the kinetic energy. I will count everything. Under this definition, mass is total energy over the speed of light squared, full stop. And notice what this alternative definition buys you. Under it, the moving tennis ball really does have more mass than the stationary one, because it has more total energy. As an object speeds up, its mass increases because its total energy increases. And, crucially, a photon now straightforwardly has a mass equal to its energy divided by the speed of light squared, because we are no longer insisting on rest energy. We just take the photon's energy, which it certainly has, divide by the speed of light squared, and call that its mass. Under this definition, the answer to our whole video would be, yes, photons do have mass. So which is right? Is the photon massless, or does it have a mass equal to its energy over the speed of light squared? It seems to come down to a choice of definition, and that should make you uneasy, because it sounds like the answer to a physical question is just a matter of what words we choose, and in a certain sense, that unease is justified, which is exactly why this angle is worth taking seriously rather than brushing aside. There is a real philosophical point buried here. If mass is just a name we give to some quantity of energy, then asking whether a photon has mass is partly a question about which energy we have decided to attach the name to. Choose to name the total energy, and the photon has mass. Choose to name only the rest energy, and it does not. In both cases, the physics underneath, the actual energy, the actual momentum, the actual behavior of the photon, is precisely the same. Nothing about the light changes, only the label moves. So the disagreement is not really about the photon at all. It is about the word mass, about which slice of a photon's energy deserves that particular 5-letter name. This might feel like a letdown, as if the grand question dissolves into mere semantics, but it does not dissolve, and the reason it does not is that the two choices of name are not equally good. One of them leads to a clean, consistent, powerful way of doing physics, and the other leads to a swamp. And which one leads where? is not a matter of taste. It is something you can actually work out by following each definition to its consequences and seeing which one keeps its footing. Now, here is something that might surprise you. This alternative definition, mass as total energy divided by the speed of light squared, is not something I invented as a straw man. It is a real definition that physicists genuinely used, especially in the early decades of relativity. It even has a name. It is called relativistic mass. The idea that an object's mass increases as it moves faster, growing without limit as it approaches the speed of light. This notion appears in serious, respected physics writing of the 20th century, in famous lecture courses, in popular accounts. For a long time, when people said that nothing can reach the speed of light because its mass would become infinite, this is the definition of mass they were using, the relativistic one, the total energy divided by the speed of light squared. So this is not a foolish idea. It is a historically important, perfectly self-consistent way of defining mass, and under it, photons have mass. Both definitions are out there. Both are internally consistent. So why did physics, in the end, settle on the one that makes photons massless and quietly abandon the other? You can see why relativistic mass was seductive and why it took hold first. It let you keep some very comforting habits of thought. It let you go on believing that mass is a measure of how hard something is to push around, which grows as things speed up, which does climb toward infinity as you approach the speed of light. It gave a tidy story for why nothing can reach light speed, the story that your mass would become infinite and no force could budge you further. And it preserved the neat, universal-sounding rule that any energy divided by the speed of light squared is a mass. No exceptions, no fussing about which energy counts. For a physicist first wrestling these ideas into shape in the early 20th century, all of that was attractive. It felt like a natural extension of the older physics, a way to fold the strange new relativity into familiar language without having to give up too much. And for a while, that is exactly how it was taught and how it was thought about. Mass that grows with speed, a single number for everything, light included. But comfort is not the same as clarity, and the habits that made relativistic mass feel natural were exactly the habits that would eventually make it a burden. Because the moment you try to apply it consistently to light, the object it was supposed to handle so smoothly, it turns on you. The very features that made it feel tidy, one definition, mass that grows with speed, infinite mass at light speed, begin to fight one another. And to keep them from openly contradicting, you have to start bolting on exceptions and special cases until the tidy single rule has quietly become a thicket of clauses. What looked like the simpler, more inclusive definition turns out to be the one that generates a mess. Let me show you the exact point where it breaks, because it is a beautiful little failure, the kind that teaches you something about how physics decides what to keep and what to throw away. This is a genuinely interesting question, and the answer teaches you something not just about photons, but about how physics works as a discipline. It is not that the relativistic mass definition is wrong. It is not wrong. It gives consistent, correct predictions if you use it carefully. The reason it was abandoned is more subtle and more human than right versus wrong. It was abandoned because it leads to a tangle, a mess of complications and special cases that the other definition avoids entirely. When you sit down and actually try to use relativistic mass consistently all the way through, especially when you try to apply it to light, you run into a contradiction that can only be patched up by inventing extra rules and extra kinds of mass, until the whole scheme becomes so cumbersome that physicists simply threw it out in favor of something cleaner. Let me show you the contradiction, because it is a lovely example of how a self-consistent idea can still be a bad idea, and of how physics chooses between competing pictures of the world. Because this is the thing to understand about all of it. Physics is not really in the business of telling you what reality ultimately is, in some final metaphysical sense. Physics is in the business of building models, mathematical descriptions that let us predict and understand what we observe. And sometimes there is more than one model that fits the facts, more than one self-consistent way to describe the same reality. When that happens, physicists do not agonize over which model is the true one, because both make the right predictions. Instead, they ask a more practical question. Which model is simpler? Which one is easier to think with, easier to use, less cluttered with awkward special cases? And they keep that one, and let the other fade away. That is exactly what happened with these two definitions of mass. Both work. One is simpler, and to see why the simpler one won, we need to watch the more complicated one tie itself in a knot, which is precisely what happens when you push relativistic mass to its logical conclusion. So let us push it, and watch it break. Part 12. Why we threw that idea away. Let us take the relativistic mass definition seriously and follow it to its conclusion, because that is the honest way to find out whether it holds up. Under this definition, mass is total energy divided by the speed of light squared, and so an object's mass grows as it moves faster, because its total energy grows. Now recall the fact we established earlier, that accelerating any object toward the speed of light requires more and more energy, without limit, so that reaching the speed of light would take infinite energy. Translate that into the language of relativistic mass. As an object approaches the speed of light, its energy grows without limit, so its relativistic mass also grows without limit. At the speed of light, an object made of matter would have infinite mass. This is actually the origin of that famous phrase you have heard, that you cannot reach the speed of light because your mass would become infinite. It is a statement in the language of relativistic mass. Going at the speed of light means having infinite mass. Now here comes the contradiction, and it is sharp. Under relativistic mass, anything traveling at the speed of light should have infinite mass. That was the whole reason nothing could reach the speed of light. But what travels at the speed of light? A photon, light itself. So a photon, traveling at the speed of light, should have infinite mass, by the very logic we just used. And yet, under this same relativistic definition, the photon's mass is its energy divided by the speed of light squared, which is a perfectly finite number. An ordinary photon of light has a modest, finite energy, so a modest, finite relativistic mass. So which is it? Traveling at the speed of light is supposed to give you infinite mass, yet the photon travels at the speed of light and has a finite mass. That is a flat contradiction, sitting right in the middle of the relativistic mass picture. The rule says infinite, the photon says finite, and both come from the same definition. Now this contradiction can be patched. Physics is clever, and there is a way to make it consistent. But watch what the repair costs you. To fix it, you have to split the idea of mass into two separate concepts. You have to define one kind of mass called rest mass, the mass an object has when standing still, and another kind, called relativistic mass, or moving mass, which grows with speed. And then you have to lay down two different rules for two different kinds of object. For things that have a non-zero rest mass, like you and me and tennis balls and planets, the rule is that their moving mass grows to infinity as they approach the speed of light, which is why they can never reach it. But for things that have zero rest mass, like the photon, you need a completely different rule, one that says their moving mass stays finite even at the speed of light. So you end up with two kinds of mass, and two separate rulebooks, one for things with rest mass and one for things without, carefully arranged so that the contradiction cancels out. It works, it is self-consistent, but look at how much machinery you had to build to make it work. Now compare that to the other picture, the one we spent this whole video developing. In that picture, there is just one kind of mass. Mass is the rest energy of a thing divided by the speed of light squared, and that is the end of it. Mass does not change with speed. A tennis ball has the same mass, whether it is sitting still or flying through the air. A photon has zero mass, simply because it has no rest energy, no special rules required. There is one definition of mass. It is the same for everything. It does not depend on who is watching, and it does not depend on how fast the object is moving. When you want to know why nothing can reach the speed of light, you talk about energy going to infinity, not mass. And there is no contradiction to patch, because the photon, with zero mass, sails along at the speed of light exactly as a massless thing should. One kind of mass, one simple rule, no special cases. Isn't that so much cleaner? And that is why physics abandoned relativistic mass. Not because it was wrong, but because it was clumsy. It forced you to carry two kinds of mass and two sets of rules, when a simpler picture needed only one kind and one rule, and gave all the same predictions. Remember what we said about how physics works. When two models both fit the facts, you keep the simpler one. Both definitions of mass are self-consistent. Both make correct predictions if you are careful. But one of them needs a tangle of special cases to handle light, and the other handles light effortlessly, by simply saying the photon has no rest energy and therefore no mass. So physics kept the simple one, and let the other one fade into history. Today, when a physicist says mass, they mean the single, unchanging, rest energy kind, and by that definition, the one we have every good reason to prefer. Photons are massless. It is not a law carved into the universe so much as the cleaner of two working maps, and knowing that is what turns the answer from a slogan into something you truly understand. There is a larger lesson tucked inside this choice, and it is one of the quiet secrets of how science actually works. We like to imagine that physics reads the universe directly, that it uncovers the one true nature of things and reports it back. But physics is really in the business of building descriptions, models that reproduce what we measure and let us predict what comes next. And every so often, as here, more than one description fits all the facts equally well. When that happens, there is no experiment that can crown one as the true one, because they make the same predictions. They only differ in how they carve up the ideas. And in those moments, physicists fall back on something that sounds almost aesthetic but runs to the core of the method, a preference for the description that is simpler, cleaner, easier to reason with, less cluttered by special cases. Simplicity is not a proof of truth, but it is a reliable guide to which map is worth carrying. And over in the history of physics, the simpler description has proven not just more convenient, but more fruitful, opening doors the tangled one kept shut. So when you hear that photons are massless, you now understand what kind of statement that is. It is not a raw fact pried from nature, like the temperature of the sun. It is the verdict of the cleaner of two working descriptions of mass, a description so much simpler and more powerful than its rival, that physics adopted it universally and never looked back. Under it, mass is rest energy. It never changes with speed, and light, having no rest, has no mass. That is the honest, complete answer, footnote and all. And it is worth far more than the bare slogan, because you can see the reasoning that stands behind it and the choice that was made. But we still have one more angle to explore, the most beautiful of them all, the one that reveals why light rides the speed limit of the universe in the first place. And it turns on realizing that the speed of light is not really about light at all. But there is one more angle, one final and more fundamental way to see why light must be massless, and it involves rethinking what the speed of light even is. Part 13. The speed of causality and where the energy comes from. We have arrived at the last and most fundamental angle, and it reframes the entire question in a way that makes the masslessness of light feel not just correct, but inevitable. Throughout this video, I have been calling it the speed of light, the ultimate speed limit of the universe, the wall that nothing can reach. But here is a secret that physicists know and rarely say plainly. The speed of light is not really, most fundamentally, about light at all. That universal speed limit is better understood as the speed of causality, the speed at which cause and effect can propagate through the universe. It is the fastest rate at which anything that happens here can influence anything that happens there. It is the speed of the connection between a cause and its effect, and it is the same for every observer, woven into the very structure of space and time. Relativity, read at its most fundamental level, is not a theory about light. It is a theory about cause and effect, about the order of events, and about the one absolute speed at which influence can travel. So why do we call it the speed of light? Why is light the thing that gets its name attached to the universe's ultimate speed limit? Because light happens to travel at exactly that limit. Photons are, in most situations, the carriers of cause and effect across space, the messengers that let one part of the universe affect another, and they ride along at the maximum possible speed, the speed of causality. So we see light traveling at that ultimate speed, and we naturally name the speed after light. But the light is not what sets the limit. The limit is set by the structure of cause and effect itself, and light merely rides it. And now watch how this reframing makes the masslessness of light click into place with a satisfying finality. Anything traveling at the speed of causality, the ultimate limit, can never be brought to rest, because you would have to reach that speed yourself to catch it, and reaching it is impossible. So anything moving at the causal speed limit has no rest frame, no rest energy, and therefore no mass. Light travels at the speed of causality, therefore light is massless. It could not be otherwise. And this opens up a genuinely startling possibility, one that lives right at the edge of what we know. We have been assuming that light travels at exactly the speed of causality, riding precisely at the ultimate limit. But what if it does not? What if photons travel just a hair below the true speed limit, ever so slightly slower than the speed of causality? If that were true, everything would change, because then the photon would not be riding the unreachable wall. It would be traveling just under it, at a speed you could, in principle, catch up to with a finite amount of energy. You could pull alongside a photon, bring it to rest, find that it has a rest energy after all, and therefore discover that light has a tiny mass. So whether the photon is exactly massless comes down to a single question. Does light travel at exactly the speed of causality, or just below it? Notice how completely this reframing reorganizes the whole picture. All along we have been treating masslessness as the cause and light speed as the effect, saying the photon travels at the speed of light because it is massless. But you can turn it around and see it the other way. Anything that is massless must travel at the causal limit, and anything that travels at the causal limit must be massless. The two are one fact, seen from two sides. A massless thing has no rest frame, no interior energy to anchor it, nothing to slow it down, and so it is swept along at the maximum speed the universe allows, the speed at which cause becomes effect. Masslessness and riding the causal limit are not two separate properties that happen to coincide in light. They are the same property, wearing two names. To be without rest is to travel at the ultimate speed, and to travel at the ultimate speed is to be without rest. And here is the honest truth about that final question. We do not know for absolute certain. Every experiment ever done is consistent with light traveling at exactly the speed limit, which would make its mass exactly zero. But no experiment can ever prove a perfect zero. All we can do is measure more and more precisely, pushing the possible mass of the photon smaller and smaller, and so far it has stayed consistent with zero, smaller than almost any number you can imagine. As far as we can tell, light rides the causal limit perfectly and is perfectly massless. But that last decimal place, the difference between exactly at the limit and infinitesimally below it, is something the universe has not yet fully revealed. So let us gather all of it together and answer, at last, the question on the thumbnail, the question we opened with. How can a photon have energy without mass, and where does that energy come from? The answer, now, should feel earned. A photon has no mass, because mass is rest energy, the energy of standing still, and a photon never stands still for anyone. It rides the speed of causality, the universe's ultimate limit, and so it can never be brought to rest, and has no rest energy to weigh. But it certainly has energy, and that energy comes not from mass, but from motion, from momentum. There is a fuller form of Einstein's famous equation, one that most people never learn. It says that the total energy of anything comes from two sources combined, its momentum and its rest mass. For an object sitting still, the momentum is zero, and the equation collapses down to the famous E equals mc squared, energy from rest mass alone. But for a photon, it is the mass that is zero, and so the equation collapses the other way, and it tells you that the photon's energy is simply its momentum multiplied by the speed of light. The photon's energy is the energy of pure motion, carried by its momentum, with no mass involved at all. The famous equation, E equals mc squared, was never even the right equation for light. It is only the resting corner of a larger law, the corner where a thing sits still. Light never sits still, so for light, the whole of its energy is motion. And this idea, that light carries momentum without mass, is not a mere abstraction. You can see its fingerprints in the real world, which is a comfort when the reasoning has taken us somewhere so strange. We usually think of momentum as mass times velocity, so a massless thing seems as if it ought to have none. But light does carry momentum, real momentum, and it can push on things. Point a bright enough beam at a delicate enough object, and it will move, nudged by the sheer pressure of light. This is why a comet, sweeping in toward the sun, grows a tail that always points away from the sun, no matter which direction the comet is traveling, because sunlight is physically pushing the comet's loosened dust and gas outward, ahead of the comet or behind it, always away from the source. It is why engineers build solar sails, great thin sheets that catch the momentum of sunlight the way a cloth sail catches the wind, and are slowly driven forward through space by light alone. The momentum of light is not a bookkeeping trick. It is a force you can feel, a push you can harness, and it is where every bit of a photon's energy actually lives. Light has no rest and no mass, and yet it can shove a spacecraft across the solar system, purely by virtue of its endless motion. And so the paradox we began with dissolves completely, and something better stands in its place. The photon was never a contradiction. It was only a misunderstanding, the mistake of dividing its total energy by the speed of light squared, when mass is made only from the energy of rest, and light has no rest. Where does a photon's energy come from, if not from mass? It comes from its motion through the world, from its momentum, from the fact that it is forever racing at the ultimate speed of the universe, and never, ever stopping. Light is the purest thing there is, energy with no still center, motion with nothing at rest inside it, weightless, precisely because it never pauses. The next time sunlight falls warm on your face, you might remember that you are being touched by something that has no mass at all, something that has been traveling at the speed limit of cause and effect since the moment it left the surface of a star, something that carries real energy purely by virtue of its endless motion. It weighs nothing, and it warms you all the same. And in that small, ordinary sensation lives one of the most profound truths in physics, that mass was only ever energy standing still, and that light, which never stands still, was free of it all along. Rest well with that thought tonight, and let the strange, weightless, restless nature of light stay with you as you drift.